Chapter number 9, Sequences and Series. Now, sequence as well as arithmetic progression AP, both you already studied probably in 10th standard. Here in this chapter we'll study geometric progression also, GP, and their means, arithmetic means and geometric means. This is what we are going to study in this chapter. So let's start first what we mean by sequence. We want to write what's the meaning of sequence here. So we know that sequence is an array of numbers. Sequence is nothing but what? An array of numbers. Array means what? Linear arrangement. Like this. If I take arrangement, for example, let's write 1, then 2, then 4, then 6, then 7, then 20, then 25, any random arrangement, right? It may not have some specific order, is called a sequence. Is called a sequence. Is called a sequence. Sequence of numbers is called a sequence. Now here, numbers in the sequence are called terms. Numbers are called the terms of the sequence. Your numbers are called terms. Terms of the sequence. Terms. So this is a first term, this is a second term, this is a third term, this is a fourth term, this is a fifth term, and so on. We usually call the numbers as the terms of the sequence. So in general, a sequence is this. A sequence is this A1, A2, A3, and so on. So this is the first term like this. This is the second term like this. This is the third term like this, and so on. In general, we have nth term here, AN, and so on, right? Sequence is this A1, A2, and so on. This is the first term, second term, third term, where AN is called nth term. Is called nth term of a sequence. AN is called which term? Nth term. A1 is called the first term. A2 is called second term. This is called third term, and so on. This is the nth term. So sequence is just arrangement of numbers in a line. This is sometimes called linear arrangement. Okay. A sequence may be finite or infinite. Sequence may be finite or infinite. Sequence may have some fixed number of terms. Fixed number of terms, maybe 10, 20, and so on. Or it may have infinite number of terms like this. If I write here one sequence, 2, 4, 6, 8, 10, 12, and so on. This is infinite sequence. Is infinite sequence. All even positive integers. Infinite sequence. Fine. Sequence, if you have, you can find the nth term of the sequence. So here you can see all even numbers, so nth term will be 2n, like this. So here an will be 2n, nth term. Why nth term is important? Because if you know nth term, you can find all the terms of the sequence. Put n is equal to 1, so we'll get the a1. So what is a1? A1, put n equals to 1, it is 2. Put n is equal to 2, so you'll get the second term, a2, which is 4. Put n equals to 3, so you'll get the third term, a3, which is 6, and so on. So once you know nth term of a sequence, you can find all the terms of the sequence by putting n is equal to 1, 2, and so on. Nth term of a sequence is also denoted by fn also, f of n, like function. Or sometimes even this Tn is also used, big Tn. Tn is also standard notation for nth term. Fn or Tn or small an, these all are the notations for the nth term of a sequence. Fine. So what we understand by sequence? A sequence is just an arrangement of numbers like this a1, a2, and so on, an. where this an is called which term of the sequence? Nth term of the sequence. Sequence may be finite or infinite. It may have 10 terms, finite sequence. Or sequence may be infinite also. That means it may have infinitely many terms. And once we know nth term of a sequence, we can describe one by one all the terms of the sequence. Okay. So that's one thing, sequence. Now we define one more, that's called the series. Here, next is definition of series. We want to write what is a series. Now series is nothing but special type of a sequence. A series is a sequence. Series is nothing but what? A sequence associated with the given sequence. Associated with the given sequence. So if you are given a sequence, you can find a new sequence from it, that's called the series. So I'll start with a sequence here. Let this be a sequence. Let A1, A2, A3 and so on, An be a sequence. This is a given sequence. You have started with this sequence. This be a sequence. We define now new sequence, which is known as series. We define new sequence here. New sequence from the above sequence. New sequence as S1, the first term of the series. S comes from the series, which is the first term of the given sequence, A1. S2, that's the sum of the first two, which is A1 plus A2. S3, that's the sum of the first three terms, which is A1 plus A2 plus A3. What is S4? Sum of the first four terms, A1 plus A2 plus A3 plus A4. And so on. In general, you have Sn, that is the sum of how many terms? A1, A2 up to An, sum of the n terms of the given sequence. So this way we have new series. That new series is actually a sequence, right? So therefore the sequence S1, S2, S3 and so on, Sn is called the series. Is called the series obtained from the given sequence. So what is the series? It's a series is nothing but what? The sequence obtained from the given sequence. Fine. So here you can have this important relation, Sn equals to A1 plus A2 up to An, sum of the n terms of the sequence. An stands for the sequence. Sn is sum of the n terms. So if you have sum of the n terms, you can get the nth term of the series. So one is this. You can do reverse also. So I'll just write here. Let's write over here. That's the I'll write sequence from series. I want to do reverse. What I want to do now? Reverse. Sequence from the series. Here what you did, you had started with sequence and you got the series. Now I want to do reverse. You are given this, I'll get the An. So what is given here? I'll write, we are given what? What's the given? You are given S1, S2 and so on. That is the series you are given. And what you want to find? To find An. To find A1, A2 and so on up to An. That's the sequence. This is a series, this is a sequence. Series means S1, S2 up to Sn. Sequence means A1, A2 up to An. Okay, so I'll do, see here. We want here A1. So what is A1? Just go back, it is same as S1. Just go back to definition of the series, you will realize. What is A2? A1 is same as S1. Now what I'll do this minus this, so I'll get the A2. So it is nothing but what? S2 minus S1. Do this. If you do S2 minus S1, just look at there, you will get the A2. What is A3? That is nothing but the S3 minus S2. See, do this. S3 minus S2. So this will get cancelled, you'll get the A3. Right? Just find this, you'll realize S3 minus S2, you'll get the A3. And so on. What is Sn? Now you can write 3 then 3, 2 then 2. So here Sn minus, here 1 less index, 2 then 1, 3 then 1. So here n minus 1. And this is applicable only when n is greater than 1. If you have 1, then this becomes 0. There is no concept of 0. So this is reverse relation. Oh sorry, here an, I'm sorry, this an, this is a reverse relation. An equals to Sn minus an equals to Sn minus Sn minus 1. That's relation between sequence and series. If you have series, you can get the sequence. Fine. Okay, I'll take an example. You will realize, let the sequence be this. Let sequence, I'm taking this minus 1, 1, minus 1, 1, minus 1, 1 and so on, infinite sequence. Now corresponding to this, I'll get the series. What's the series? So therefore series means what? New sequence. Series S1 is first term, which is minus 1. What is the second term? This is S1, which is same as A1. What is the second term here? That's the sum of these two, which is 0. So this is S2. What is the third term? S3. How do I write? Sum of these three, that is minus 1. What is the S4 here? S4, that is sum of the first 4, which is 0. 1, 2, 3, 4, which is 0. Then sum of the first 5, that is minus 1, that is S5, and so on. Right? This is a new sequence obtained from this, which is known as series. Fine, that's one thing we wanted to know. Okay, now that's all in all about just what is the sequence and what is the series. Now we go to here next exercise, which is first exercise of this chapter, which is 9.1. Very simple exercise. Write the first 5 terms of each sequence given in 1 to 6. So question number 1, an nth term you are given, n into n plus 2. How do we get the first 5 terms? Just by putting n equals to 1 to up to 5. So put n equals to 1, 2, 3, 4 and 5. You want 5 terms. So what is a1? 1 into here 3. So this is 1 into 3. So it will be 3. What is a2? This is 2 into here 4. So 2 into 2 plus 2, which is 4. So this is 8. What is a3? That is 3 into 3 plus 2, which is 5, which is 15. What is a4? Fourth term. That is 4 into 4 plus 2, which is 6. So it's 24. What is a5? That is 5 into 7. That is 35. So these are the first 5 terms. 1, 2, 3, 4 and 5. You are asked for 5 terms. What we did? Nothing. You are given nth term. Just what you have done? You have placed n equals to 1, 2, 3, 4, 5. Finished. Okay. Next, I'll go to fourth sub question. All are very simple questions. I'll not take much time in this. Right. Now put for first term 5 terms 1, 2, 3, 4 and 5. So I'll get the a1. That is 2 minus 3 by 6, which is minus 1 by 6. What is a2? That is 4 minus 3 by 6, which is 1 by 6. What is a3? Here I'll put 3. 6 minus 3. 6 minus 3 by 6, which is how much? 3 by 6, which is here 1 by 2. What is a4? Put 4. 8 minus 3 by 6. How much? This is nothing but the 5 by 6. What is the a5? Put 5 here. So 10 minus 3 by 6. So this is 7 by 6. These are the first 5 terms. Fine. So that's too simple. Now from 7 to 10, again you are given nth term, but there you are asked to find indicated term. So there I'll do the seventh question here. You are given an equals to 4n minus 3. You are asked a17 and a24. So just place the value. So what is a17 here? That is 4 into 17 minus 3, right? So this is nothing but the how much? You have 68 minus 3, which is 65. Fine. Now, so that is nothing but the 4 into 24 minus 3. So this will be 96 minus 3. So here it will be 93. Okay. Now, the next I'll go to ninth. Let's see ninth. There an equals to minus 1 raised to n minus 1 into n cube. You want a9. So I'll just put n equals to 9. a9 equals to minus 1 raised to 9 minus 1, which is 8, and this is 9 cube. Fine. So here, what is this? This is 1, and 9 cube, that's nothing but the 729. This is minus 1 raised to even power. So it will be just 729. Okay. The next, now from 11 to 13, these 3 questions, you are asked obtain the corresponding series. Okay. So in these 3 questions, you are given the sequence and we are asked to find the series. So question number 11. Let's see 11th question. There you are given a1 equals to 3, first term. And what is an? An is nothing but the 3 into an minus 1 plus 2. You are given the sequence here. We get the series corresponding to this. So here we have a1 equals to 3. Get a2. Put n equals to 2 here. What is a2? That is 3 into, put n equals to 2. a1 plus 2. So put now a1 here, 3 into 3, 9 plus 2, which is 11. So a2 is 11, a1 is 3, a2 is 11. Okay, now we go for a3. So put n equals to 3 here. 3 into a, here 1 less, that is 2 plus 2. So here if I put 11, this will be how much? 33 plus 2, which is 35. So a3 is 35. One more you can find if you want. So here let me find a4 also. What is a4? That is 3 into a3 plus 2. Right? Each term depends upon the previous term. You see, a2 depends upon a1. a3 depends upon a2. a4 depends upon a3. So what will be this? a3, 35. 35 into 3 plus 2. So it will be 105 plus 2. So 107 here. So sequence is this. Given sequence, remember. That is 3, then 11, then 35, then 107, and so on. Right? You can continue. This is just I have written given sequence. We don't want sequence, we want the series. So therefore this is the question. Series is, what is that? Sum of the n terms. So it is 3 plus 11 plus 35 plus 107 and so on. This is a series. This is first term. This is a second term. This is a third term. In general, if it is nth term, then sum of the n terms. This is a way of writing. This is a series. Fine. First what we did, we got the sequence and then from there we wrote the series. Now let's see next. We'll go for 13th. I'll be doing 13th for you. Question is same. You are given a sequence, you want to get the series. So in the 13th question, a1 and a2 both are 2. And an equals to a n minus 1 minus 1. Now a1, a2 you are given. So put n equals to 3 here. So we'll get the a3. We are finding first 4, 5 terms of the given sequence. So put 3 here. So 3 minus 1 which is 2. a2 minus 1. So 2 minus 1 that is just 1 here. 2 minus 1 which is 1 here. And next let's find n equals to 4. Fourth term. So this is 4 minus 1 which is 3. a3 minus 1. What is a3? That you did here. That is 1 minus 1 which is 0. So fourth term is 0. So I have, you can find the fifth term also. I have obtained here terms. What are the terms? The first two terms you already given. So sequence I'll write 2, 2, then 1, then 0, and so on. You can write further. So what will be the series from this? You can write just as a summation. Series, you know, it is the sum of the n terms. So series will be 2 plus 2 plus 1 plus 0 and so on. You can write this way. Fine. The first term of the series is 2. Remember here S1 is 2. What is S2? That is the sum of the first 2. That is 4. What is S3? That is the sum of the first 3, which is 5, and so on. But this is the standard way of writing the series. Just write the sum of the given 4, 5 terms. Fine? Okay. Now question number 14. 12th you can try same way. I'll go to question number 14. Last question. You are given one sequence which is called Fibonacci sequence. Their first two terms are known to you. A1 and A2. Both are 1. And an, that is an minus 1 plus an minus 2. This is actually nothing but sum of the previous two terms. Is it? See, you get the a3 from this. a1 and a2 you know, n equals to 3. So if I put 3 here, 3 minus 1 which is 2, 3 minus 1 which is 1. You see sum of the previous two terms which is 2. What is a4? It has to be the sum of the previous two. Put n equals to 4 here. So this is a3 and this is a2. So a3 and a2 which is 3. So your given sequence is this Fibonacci sequence 1, 1. What is the next term? That is the sum of these 2, 2. What is the next term? Sum of these 2, 3. What is the next term? 5. What is the next term? 8. Sum of these 2 and so on. This is the given sequence. What you want? We want this a n plus 1 upon a n. For n is equal to 1, 2, 3, 4, 5. Right? So first I'll put n equals to 1 here. So what we'll get? a2 by a1. You want actually successive ratio. a2 by a1. What is a2 by a1? Here n equals to 1. 2 and 1. a2 by a1 is just 1 by 1 which is 1. Next put n is equal to 2. It is a3 by a2. Successive ratio. a3 by a2. What is a3 by a2? This by this. This is a3 by this. So 2 by 1 it is 2. First you took this ratio, then this ratio. Now obviously this ratio. So if I put n equals to 3, here if I put n equals to 3, what will get? a4 by a3. Okay, where is a4? This one. a1, a2, a3, a4. So a4 is 3 by 2. So we have 3 by 2 and so on. Further you can do for n equals to 4 and 5. Do this. It's very simple. So that's this exercise.